Welcome to the Bentley Systems training course where you will learn how to use the iTwin services to push and pull a model from the cloud into the STAAD.Pro Physical Modeler. Now before we get started, let's talk about Bentley's integrated structural modeling. This is a technology for sharing structural engineering project information among structural modeling, analysis, design, drafting, and detailing applications. It's similar to building information modeling, but it focuses on the information that is important to the design, construction, and modification of the load-bearing components of buildings, bridges, and other structures. Now, the iTwin services allows you to access two modes of file synchronization, cloud and file-based. The file-based workflow allows you to synchronize your model to a local file, while the cloud-based workflow allows you to synchronize your model to the cloud. For this training video, we are focusing on the synchronization through the cloud, specifically how to pull an iModel into the STAAD.Pro Physical Modeler, and then how to push your changes and design results back to your iModel on the cloud. Now, using the iTwin services, it won't be necessary to model your structural system in multiple applications, including your BIM application and your structural analysis and design application. This will ensure your changes are incorporated quickly and accurately. In addition, the cloud-based workflow provides interoperability and collaboration solutions for dispersed teams. So instead of maintaining a repository locally, the repository will exist on the cloud, which will allow your team to work more effectively with each other. Your first step for utilizing a cloud-based workflow in your iTwin services is to create your project in the infrastructurecloud.bentley.com. Here, you would register your project and create your iModel. For this session today, you can see that I've already created my project on infrastructurecloud.bentley.com. And as you can see, our iModel was already created. So iModels will help you share model and project information. And I typically think of them as containers for exchanging infrastructure information through the life cycle of my infrastructure asset. This particular iModel was created from my BIM model. Now, my BIM model for this exercise was created in Open Building Designer, but Revit Structure can also create an iModel in the Infrastructure Cloud. So let's go ahead and turn our attention to our STAAD.Pro Physical Modeler. As you can see, I've already created a new model in the Physical Modeler, and I'm ready to create some model information. To access my iTwin services, select the Model tab in the ribbon toolbar, and then I'm going to click on the iTwin services icon. Once the iTwin services dialog appears in the data area, I can select which form of synchronization I'm interested in. For today's session, I'm going to go with a cloud-based workflow. Next, I'm going to take a look at some of the settings that are available for the iTwin services. I can review my model offset information, my interoperability settings, and my tolerances. For this example, I'm going to go ahead and set all of those equal to their defaults. Now at this point, I'm ready to pull my model in from the cloud. To do that, let's go ahead and click on the Pull from Cloud option. Upon selecting this option, the STAAD.Pro Physical Modeler will ask me to authenticate or log into my account. Once I'm logged into my account, I'm going to select my digital twin connection. Here I can select any projects that are assigned to myself in my infrastructure cloud. Here I'm going to go ahead and select my steel trellis project and my steel trellis iModel that's associated with that project. Once I've entered all of my information, let's go ahead and click on the Confirm option, and we're going to pull the existing iModel in from the cloud. Now before I do that, I'm going to select this checkbox here. This is to show our change management. When this option is selected, I can manually select which objects I would like to pull in from the iModel versus which ones I would like to reject. I'm going to go ahead and keep this on so I can review all the information in the iModel and selectively decide what belongs in STAAD.Pro. Since I selected Change Management, the iTwin Analytical Synchronizer will appear on my screen. This will allow me to review the iModel in its current condition and select which objects I would like to pull in to STAAD.Pro. What I like to do is I like to select everything on my model and click Accept, and then I'm going to click on the Preview button. This will let me know what the model is going to look like upon entering STAAD.Pro. Now for this particular model, I'm planning on designing the steel trellis in STAAD.Pro, and the rest of the objects within this model won't be designed in STAAD.Pro. And this, for this iModel, would include the pier and concrete foundations and any other architectural components. Now that being said, let's go ahead and unselect certain objects within this particular model. So here I can go ahead and take a look at any elevation of the model, and I'm going to select, say, my piers and footings. Once I select those, I can click Reject. Now I can see that the iModel has been updated and the piers and footings are not eligible for being brought into STAAD.Pro. I'm also seeing some architectural components, so let's go ahead and reject those as well. Now, if I go back to my isometric view, I'll have an opportunity to review the rest of the information that is getting ready to be pulled into STAAD.Pro. This information for this particular model includes my entire steel trellis and these steel plates that are at the top. This is exactly what I was looking to create in my STAAD.Pro model. So I'm going to go ahead and update STAAD.Pro with this information. To do that, I'll go ahead and click on the Update button, and that iModel with all of my requests is now being pulled into the STAAD.Pro Physical Modeler. Now that we've successfully pulled our iModel into the STAAD.Pro Physical Modeler, let's discuss where we go from here. The first thing I'm going to do is review the imported model. This will include performing an integrity check and reviewing my nodal and member properties. Next, I'm going to complete all my modeling steps. This will include any information that doesn't currently exist in the iModel. This may be things like member specifications, load cases, and analysis commands. Finally, I will perform my design in the STAAD.Pro Analytical Modeler before I push the model back to the cloud. So to start an integrity check, I'm going to go up to the ribbon toolbar, click on the Model tab, followed by the Integrity Check icon. This will let me know if I have any duplicate or orphan nodes, also if I have any overlapping or duplicate members or services. I will validate this system and none have been reported. So let's go ahead and click Close. Let's also take a closer look at this model, and I like to take a look at it in both elevation and in the isometric view. Now what I'm noticing is that I do have this beam member for this particular model that should be running from column to column. As you can see, the nodes are not quite lined up to the column. Now more than likely in the BIM model, this beam member was drawn from face of support to face of support, which means their nodal locations aren't quite lining up in STAAD.Pro. To ensure that this beam is properly connected to this column, I can go ahead and move their nodal locations once in the STAAD.Pro Physical Modeler. Now that I have adjusted my nodal locations, it's also good practice to reperform an integrity check. Here I can see I do have a few duplicate nodes, so let's go ahead and delete them and revalidate our model. After performing an integrity check, it's also a good idea to review any of the section properties and material properties that were pulled into the STAAD.Pro Physical Modeler. To make any changes to these properties, go ahead and select the Catalog tab. The Catalog tab will contain all of the section properties and material properties that were available in your iModel that were then pulled into STAAD.Pro. Let's go ahead and take a closer look at our ASTM A992 grade 50 material that was brought in. Now here I can see that the yield strength of steel is not quite appropriate as I would like as a structural engineer. So I'm going to go ahead and change this to 50 kips per inch squared, and I can also adjust the ultimate strength. I can review that information for each of the material properties that were brought in and are currently assigned to the model. Now, after reviewing your imported model, you're then ready to move on to your modeling steps that would take place in the STAAD.Pro Physical Modeler. This would include adding any type of support information, any additional member specifications, and load cases, load combinations, load items, analysis and design commands. Now for this particular model, I just went ahead and added all the necessary information that I as a structural engineer will need for the full analysis and design. For this particular structure, that meant adding in some ports, adding in all the necessary load cases and load combinations, specifying the appropriate member specifications, including the member end fixity, and also adding the analysis commands. We're now at the point where I'm ready to move on to the analysis and design phase of my structure. I've built my analytical model from the physical modeler, and I've also assigned some steel design commands. Let's go ahead and run our analysis and see how we're doing so far. After the analysis is complete, I'm going to check for any errors or warnings and then proceed to the post-processing mode. Once in the post-processing mode, I'm going to check out my utilization ratios. Here I can see that I have several members within my model that are currently failing the code check. If I wanted more information, I could select this failure tab and select all the members that are currently failing. Now at this point, I've decided that I'm going to go ahead and adjust the sizes of these members to something that would be a little bit more satisfactory. So I'm going to return to the STAAD.Pro Physical Modeler and make some changes. Now at this point, let's go ahead and say that I've already gone through my code checking for my steel trellis system, and I've gotten all the members to a passing condition. If I wanted to see that in a post-processor, I can go to the post-processor after an analysis is performed and take a look at my utilization ratios. And I could also confirm that there are no longer any failing members. Now, several of these members did change size. Actually, a couple of them even changed shape during that process. So now what I want to do is I want to push this model back to the cloud and update the iModel. That way those changes are available for anyone else working on this project, including the BIM manager. So let's go ahead and do that. I'm going to return to the physical modeler and select iTwin services again. Now I'm going to synchronize to the cloud You can see that my model and iModel are still selected. And before I push it back to the cloud, let's go ahead and edit our settings. Now, I didn't change anything for the offset settings, but if I were to take a look at the interoperability settings, I have a new option down here that's available to me at this point. These are the design results. Now, I do have design results associated with this model, and if I wanted to review that information, or if anybody else on my team wanted to review that information directly in the cloud, they would be able to if I select this option. This would include your design parameters and your resulting interaction ratios. Now at this point, let's return to the iTwin services and push this model to the cloud. Again, I may be asked to authenticate my login. Now I'm going to go ahead and name this version STAAD Steel Design Results. And I'm going to take a look at this checkbox again. This is the Show Change Management option. Now for this particular model, when I pulled it in from the cloud, I didn't pull in every single element. I chose not to pull in the footings or the piers yet, and there were a few other architectural features that I chose not to pull into my STAAD.Pro model. Now that being said, if I leave change management unselected, it means everything from this model would be accepted upon pushing it to the iModel. And I don't want to actually delete those footings, piers, and architectural features from the iModel. I just didn't want them in my STAAD.Pro model. So I'm going to keep the change management selected so I can tell the program that I don't intend to delete those items. Let's go ahead and click on the push button. Now, since the change management option was selected, I can go ahead and see what the iModel looks like at this point. You can see that all the different objects are characterized as either added objects, deleted objects, or modified objects. And this is a great place to go if you want to make your changes or incorporate your changes in your new iModel. Let's go ahead and start by filtering on the deleted elements. And I can go ahead and take a look at these different options, and I can see that these are basically some nodes, some footings, some surface members. So these are all of my footings, piers, and architectural elements that I chose not to bring into my STAAD.Pro model. I'm going to go ahead and reject these changes. I want these items to still be in the iModel, so I don't want to officially delete them. So let's go ahead and say select all, followed by reject. Now let's go ahead and preview what we have so far. Okay. Now at this point, let's go ahead and see any added items. Okay. This will include any of your analysis results, your design results, all of those loads and supports and additional information that I added within my STAAD.Pro model. So I can go ahead and take a look at these items one by one, and if everything looks good, let's go ahead and say select all and accept. Again, I like to finish off by clicking on the preview button. Now the last thing I'm going to do is take a close look at the modified items. Now here I can see some concrete information was modified. Some members. You can see here I changed from a W10 by 12 to an HSS member. I can see that some steel material properties changed. Story information was added, and then some plate information also changed. Now after reviewing these modified parameters, I want to go ahead and accept them for this model. Let's go ahead and say select all and accept. I can preview my model once again, and then I can go ahead and officially update my iModel. I'm going to flag this as a major change and call it STAAD Steel Design. Finish this off by clicking OK. We're processing the changes, and now that information is being sent to the iModel, which is on the cloud. You can see my repository has been updated successfully, and now we can go ahead and review that information on the cloud if we'd like to. So let's go ahead and take a look at that model on the cloud. Here I've navigated back to infrastructurecloud.bentley.com. I can select my steel trellis, and let's take a look at our iModel. Once the iModel is loaded, you'll be able to review all of your objects over in the data pane at the right-hand side of your screen. You can also selectively turn on and off different types of items. For example, let's go ahead and turn off the loads, and I'll be able to see my iModel. And if I were to select any member in my model, I'd be able to see the properties that are assigned to that member, including the material properties and the profile information. Now let's say I want to go ahead and review my design results in the cloud. To do that, let's click on this menu here and select the analytical model. Once within the analytical area, we can review a variety of different pieces of information. Here, let's say I want to go ahead and review the strength check utilization ratios. Here I can see all the members that have been designed so far in my design platform, which for this case was STAAD.Pro. I can also see that the members have been color-coded based on their interaction ratios. Now for this particular model, I can see that all members have passed the necessary code checks, as there are no members with an interaction ratio greater than 1.0. Now let's say, for example, I want to take a closer look at the design for an individual member within the iModel. Let's go ahead and select any member on screen. And what we'll be able to see is we'll be able to see the member in its design results. Here I can see the strength check results. I can see the interaction ratio information and the capacity and demand information. If I wanted to go a little further, I can also take a look at the design criteria and design parameters that were assigned to this particular member in STAAD.Pro. Lastly, I could also take a look at the load cases and load combinations that were used to design this particular member. Now at this point, I've completed my workflow on my end. As a structural engineer, I went ahead and designed the steel trellis system. I sent the design results and the updated sizes back to the iModel. At this point, the BIM manager can go ahead and update the BIM model with the new sizes and information that are contained in this model, and we can proceed on with the rest of our workflow. Now this completes our workflow for today, and hopefully you have all the tools necessary in order to perform a successful cloud-based synchronization process with STAAD.Pro. For more information on the iTwin Analytical Synchronizer, please click on the link below in the comments.